I'm also going to turn on captions. And we'll put that up here where I can see all of that. And, oh, that's what I want to do. Well, shoot. Hold on. Okay. For those that have not printed out what I told you to print out, here is the main page, and files is right there, and the formula sheet is right there. So for those of you that have no clue where this is, since the first day of class, I ain't gonna say anything, but anyway, there is the formula page. And today I'm going to be going over 3.4 material, because I know a couple of the questions is probably going to come from 3.4 since we haven't covered it yet. And this is what we're going to cover in 3.4. Those 5 lines right there. I can't, there we go. All right, so hopefully you've written those down. And let's get back to the homework questions. So go back to post, go back to join. I know there's an easier way of doing this, but I haven't got used to. Are we recording? Are we still recording? Yes, we are. All right, so I'm gonna move this back up and pull in the handy dandy email. And I got a lot of questions from 3.2. I don't know what this is. It says GR, so I don't know what that is. GR. Okay, I don't know. Somebody tell me what GR is. Is that at the beginning? Is that in the homework? I guess it is. It wouldn't be sent to me. Let me look and see what this says. It looks like this is the basic. Then we'll go to 3.2, and then I got some 3.4 and 3.5. So whatever GR is, anybody got any input on what GR is? Okay, well, I'm gonna click on it. I'm looking to see what homework is out of. Linear relationships. Linear relationships means a straight line. So let's see what this is. I'll tell you, first of all, if it's a test question or not. Oh, that's something else. I need to go over the test stuff, because I've got some of y'all asking questions, and you don't need to be asking questions because we're not through yet about the test. Okay, it says, let E be a college enrollment at 2 years since it begins some pairs, blah, 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 showing blah, 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 blah. Create a scattergram. All right, well, if you got your calculator, we're going to do it in the spreadsheet. We're going to do it in the calculator. So let's do it in the calculator first. So get your calculator out. And we're going to go to Stat and Edit. So Stat and Edit. And I'm going to type these in. So 0, 1, 2, 3, 4. 1, 2, 3, and 4. And I'm going to just delete those others. Everybody with me? And now I'm going to go over to my next one and type in 2, 5, 8, 11, 14. 2, 5, 8, 11, and 14. And this is how you type in your table in the calculator. Now they want you to do a scatter plot. So you hit second, y is equal, see it says stat plot. And you hit the enter button because you want to turn number 1 on. You hit enter. And I'm going to pick the scatter plot, which is the first one. Hit enter. And it's going to default to L1 and L2. Now, you can either use L1 and L2 all the time, or you can use L3 and L4, but when you get to this page, you have to change that to L3 and L4, and that is second. And there's, see your L1s and L2s right here. L1, L2, L3, L4. That's what you do. But you don't have to do it if you just use L1 and L2 all the time. And hit graph. Oops, my bad. I got a limit function in there from yesterday. Sorry about that. I suck. There we go. Now, I only got 3 points, so we need to fix that. So we need to put go to zoom and stat, which is 9. There you go. Now, somebody tell me what that is. That's a straight what? That's a straight line. So they're probably going to ask you, well, what is the slope and the y-intercept? Then you go to stat, calculate, and go down to linear regression. And it defaults to L1 and L2, and you hit calculate. Now, I'm not going to explain linear regression to y'all because y'all have been through Algebra 1 and Algebra 2 before. They give you the standard form of a line, y is equal to mx plus b. So y is equal to 3x plus 2. So the standard form of that line is y is equal to 3x plus 2. You need to write that down because this is a possible test question. Okay, so let's see what they're going to ask. Well, which one does it look like? Well, it doesn't look like B. Let me move this. Let me just get my calculator out of the way. Doesn't look like, it looks like A, C, or D, and of course you're going to have to blow it up a little bit and hit C. And then you're going to see it looks like about a 45-degree angle. And when you go back to your handy-dandy calculator graph, you see it looks about like a 45-degree angle. Another thing that gives it away, is this at 0, 0, or is this at 0, 3? It's not 0, 0. A is at 0, 0. See? It's at 0, 0. And that one, it's nowhere near 0, 0 or 0, 3. So it's not that one. That one's at 0, close to 0, 0. So the only one it could be is Charlie. Choose the correct linear model. Well, where's the only one that hits at 0, 3? This one. Predict the enrollment where X is 7 years. So let's go to this is another trick on the calculator. Take your calculator and go to window or table, second graph. Oops, I don't know why it's doing that. I got it set different. Hold on, second table set. Start at 114. I don't think so. Let's just start at 0. No, let's start at -10. -10, 1, and second table. There we go. Now, why is it supposed to give us the... I don't know why it's not doing it. It's supposed to give us X and Y. Huh. Hopefully, when you do it on your calculator, it'll give you values for Y. Check on your calculator. Somebody tell me Is it doing your values for Y? I think
When I do it on my calculator, I get window range error.
Well, you hit the you hit the window. You need to fix the window. -10. Well, don't mess with the window because the window is set on Zoom stat, so you want to leave that alone. Okay, and I don't know why. So you can do it by hand. I don't know why it's doing it. When you hit second, excuse me, when you hit second graph, it's supposed to give you values for Y. I don't know why it's not doing it. Okay. Hold on a second. Walter. Walt. My daughter's calling me and I can't talk to her. I don't know why it's not doing it. It's supposed to do it. But anyway, if you want to type in 23, type in 7, let me pull up my handy dandy. You know that the formula, what was it? Y is equal to what X plus 3? What was it? Plus 3. Somebody tell me what it was. That's all right. I'll do it. Appreciate y'all's input. Second, or stat, calculate, linear regression, calculate, three x plus 2. I'm sorry. 3x plus 2. So your formula is y is equal to 3x plus 2, and they want to know 7, right? So y is equal to 3 times 7 plus 2, which is 21 plus 2, which is 23. Now you can do that either by trace or you can do it by the window. Why I don't understand why ours is not working, or you can just plug it in by hand. Predict when the enrollment reaches 32,000. That'll be 32 is equal to 3x plus 2 minus 2. 3x is equal to 30. X is equal to 10. So in 10 years, or you'd put it to whatever, should be 10 years. So type in 10, and that should be the answer. This is a good test question. Now, if you wanted to do it by the Excel spreadsheet, you would do this. You go into Excel, and you would type in the numbers.
One message coming in on secure
Now she's going to blow my phone up. So if you got an Excel spreadsheet, let me go ahead and make it a little bit bigger so y'all can see what's going on. Let's see. Increase. Y'all should be able to see my spreadsheet. Hopefully y'all see it.
Yes, sir.
Yes.
Okay. All right, I'm going to put those numbers in. Usually they give you a little tab where you can just move them over, but they didn't do that here, and I'll show you that in just a minute. So T is 0, 1, 1, 2, 3, 4. And then E is 2, 5, 8, 11, 14. 2, 5, 8, 11, 14. Walt, call your sister and tell her that I'm teaching. Find out what she needs. Okay, so now highlight this and then go to Insert. And go to Charts. hit the down arrow, and there's your chart plot. I call it chart plot, whatever they call it. Click on it. Gracious, this thing's going slow. Either it's going slow or I'm not punching the right buttons. There we go, finally. All right, now hit right click on one of the dots. Okay, this is there. Right click, add trend line. That's a fancy thing for saying, give me the equation. And hit display equation on chart. There it is. And you should feel good about yourself. Y is equal to 3x plus 2. So that's the way you can do it on Excel. All right. So let's move on because we need to move on and get some more stuff done. That problem is a good test problem, and you should be able to do it on your calculator, most of it. Okay. That's a good test question. Next one. And I'm going to go, that takes care of that one, so I'm going to delete it. Now, all these 3.2 questions, let me see if I can, why do they, okay, these are all three, okay, they're in order of going down. And some of y'all are sending the same questions, so that's good. I can just cover one. 3.2, 16/8. 3.2, 16 in the book, number 8 online. First of all, is it a test question? It's out of chapter 3, so chances are it is. If it ever comes up. Eventually. Yes, it is a test question. All right, now what they're asking, it says match the histograms on the right to the summary statistics given. Okay, now this, if you paid attention, Tuesday, I told you that the mean goes where? In the middle.
In the middle.
And then what do you do on the right-hand side with the standard deviation? You what? You add the standard deviation, Hubert. That's right, class. Glad y'all were listening. And what do you do on the left?
Subtract it.
You subtract the standard deviation. So let's take the first one. We're not even going to look at the pictures yet. Let's just take the first one. We got a mean of 57. I wonder how many of y'all actually printed out the curves. How many of you printed out the curves? Let me know. I want to see the hands. Let me see the hands. How many of you printed out the sheet that I did the curves? Okay. Wow. Darn. I was expecting like one. Okay. Okay, well, good. I'm very happy about it. I'm happy with 3 or 4. That's good. All right, so here we go. And the first one says I got a mean of 57. And I'm going to add 6. Is that 1.6? Yeah, 1.6. Now, I'm not going to sit here and add 1.6. So I'm going to add 2. So that's going to be what? 59. 61, 63, 55, 53, and 51. Now you need to do yours with the decimals. So you need to take 57, what was it, 58.6? That first one would be 58.6, wouldn't it? Somebody give me the one on the left. What's 57 minus 1.6? Dang old 55.4? What is it?
Yeah,
That's right.
55.4. So your decimals will be reading like that. All right, so that's one. So I'm going to go to another one. Let's draw another one.
I'm not seeing anything but the actual question.
I'm sorry, I suck. I'm glad you finally said something instead of waiting until the end of the problem. There we go. Is that better?
Thank you, sir.
And I've also figured out how to, I did yesterday. There we go. I took all the stuff off the edges. I figured out how to do that. All right, so here, number 2, 64 is your mean, and I'm going to add 12. So that means just spread out. That one's a bad one. That one, number 2 and number 4 is spread out. So 64 plus 12 is 76. 76 plus 12 is 88. Somebody help me out. And 100. Y'all check those numbers for me. 64 minus 12 is 52. 52 minus 12 is 40. 40 minus 12 is 28. Somebody check those for me.
They're right.
All right, let's do the third one. 57 and 9. 57 plus 9, I'm sorry. 57 plus 9 is 66. 66 plus 9 is 75. 75 plus 9 is 84. 57 minus 9 is 48. 48 minus 9, hell, I don't know. 39. 39 minus 9 is 30. And then the last one is 57, and that's the worst one because it's got a spread of 20. So that means you got 77, 97, 117 maybe, 37, 17, and freaking -3. Now you got to just match them up. But you'd be surprised on how many people get confused just by the question. Okay? So you just need to look at these numbers down here. I'm going to pull. All right, here's one that's got the middle, and it looks like, I don't know, well, wait a minute, 57, that's that one. Got 3 57s. 57 there, 57, okay, this one is 64. So you know C is the 64, which is 2. What did she want? Okay, well, tell her to come by here and we'll go get one.
She wants to put
She wants to what?
She needs to put storage bins in her room just for a little while.
Okay. All right. Okay, next, you got 3 57s right here. So you need to look at the end number. You got 57. Okay, first of all, C is out. That one's done. Okay, so you got 57 and then 87. 57 and 87, that looks like 20 or 10. Let's see, what's 57 plus, that's a 10, that's 10, that's a 10. That might be the 12 right there. So let's look. Let's look at this one. 57 plus 20 is what? That's 5. So D is what? Or 4, sorry. D is 4. So we've got C taken care of, and we've got, so all you got to do now is just figure out A and B. Well, 57 plus 1 is what? 58. So that's probably going to be that number 1 right there. So A is going to be 1, and that leaves what? 3?
Yes, sir.
That's it. So this is a prime example of drawing the curve. Okay, now, why does my curves not look like their curves? Because I'm just drawing it on a normal curve. Okay, I'm not worried about that because I'm looking at the bottom. I'm looking at the bottom numbers. That's what I'm looking at to match it up. I'm looking at these. And two of them are very distinctive. Which one are very distinctive? The plus 12 and the plus 20. Those are very distinctive. Okay, so that's a good test question. Next, let's erase that one. 3.223, we got four of these. Okay, so 3.223 slash 9, which is number 9 on your own line. First of all, is it a test question?
I hope not.
2 or 3 days later, is it a test question? Yes, no. It's a good test question if they cut the table down to about half the size. This is a good homework problem. All right, and you should do it on Excel. Why? Because you don't have to type them in. Look here. This is a trick I learned in the war. You see that little icon right there? You hit that, and it sends it to StatCrunch. Now, you can do StatCrunch and do it a whole lot quicker. Okay, I want to show you. Go to StatCrunch, and it'll pull it up, and you just hit, and it takes a minute for StatCrunch to come up. And there they are. And they're not in order, so you probably need to put them in order. And I really don't know how to put them in order here. Let's see, data. And probably somewhere in here, arrange. Nope. Sort. Variable, select columns, that variable. And I want to, let's see which way it sorts it. Okay, sort by. Okay, ascending. Look there, it's a miracle. All right, everybody good there? Now, all you got to do is hit Stat, Summary Statistics, column, hit the variable, and hit Compute. Look over there. So write all that down. And if you want to do graph, do a chart plot, or let's see, what is it? Box plot? No, not a box plot. Whatever they scatter plot. Select variable and compute. Okay, I don't have a Y. Does it have a Y variable? I don't think we do we? We don't have a Y variable, so I can't do a chart plot. Okay, so that's not what they're at. They're probably not asking for that. So write those down. Your N is 50. That means there's 50 scores. You got a mean of 0.8384. You got a variance of 0.0038, which gives you the square root of that is 0.0618. And the median is 0.84. The range is 0.26. And there's your quartiles. Okay? So that's one way to do it. Another way to do it is to send it to Excel. Now, I would suggest doing both of those unless you want to go through the pain of typing all those in your calculator. I'm not going to do that. I'm sorry, I'll do it with a little one, but I'm not going to do that with 50 dadgum numbers. All right, so here comes my Excel spreadsheet. It's pulling up. And eventually this will go away. And I'm glad we have 2 hours. I don't think we're going to make it. There we go. And there is, now I'm going to leave it small so I can get everything done. I'm going to put them in order. So I highlight the whole column. And I go to data. And you can either hit the ascending or you can go through here and do it manually. I just hit this one. There it is. Now, I told you whenever you're given a problem, do everything. So we're going to do everything. So here we go. Mean. Mode. Range. Mid-range. Hubert, you haven't even looked at what the question's asking. No, don't need to. Because I told y'all that whenever you're given a set of data, if you do this every single time with your homework problems, you won't only have the correct answer, but you'll be ready for the test. Variance and standard deviation. And I'm also going to do the 5-number summary. 5-number summary. Why? Because this one's got a lot of numbers, and the 5-number summary is best done when you got a lot of numbers. Mean, quartile, second quartile, third quartile, and max. And put the mid-range down here so you'll have it. Mid-range for the center of the, and that's going to be equal to whatever that number is right there. Okay, so let's do our mean. So I'm going to sum up all these numbers over here. So I'm going to hit the sum button, which is right here. And I'm going to highlight all these numbers. Now remember, you either need to find out how to, for the homework, you either need to find out how to do this by the Excel spreadsheet or and I would use if you really suck at the Excel spreadsheet, then I would really use the, what is it called? StatCrunch, because you don't have to learn anything. You just have to do what I told you to do on StatCrunch and you do it. All right, divided by 50. There's the mean. Median. We got 50, right? So we've got to find number what? 25. 50 is, we're going 24, 25, 26. We got to go to 25 and 26. And we got to average those up. I'm going to highlight those. And that's going to be this number right here. Highlight. And that's equal. What do we do to those two numbers since it's even? We add them together and divide by what?
2.
Divide by 2. Thank you for participating. Mode. I don't care about the mode. Y'all look that up. I'm not going to spend time on this problem. I think most of y'all know how to find the mode. It's the one that shows up the most. The more decimals you have, the less you're going to have a mode. The more whole numbers you have, the more you're going to have a mode. Decimals, I see 0.81, I see 0.82. Y'all go through there and find it. I'm not going to worry about the mode. Range, that's equal to the highest minus the what?
Lowest.
Highest minus
Lowest.
lowest. Okay, mid-range, that's equal to the highest plus the lowest, or the lowest plus the highest, because addition is commutative. It doesn't matter which one you do. Divided by 2. And that should be your mid-range. Y'all check these answers with the answers from StatCrunch. Should be about the same. Variance. Well, remember, let's pull in our handy-dandy whiteboard. And Hubert told us to print this out, so we would have the formula for the 3 or 4 people that did it. Variance equals the summation of x minus x bar, quantity squared, over n minus 1. So what do we got to do to each x?
Sum them.
Subtract the what?
The mean.
So minus that number right there, and I'm going to hit function F4 to lock it so it won't read everything down below it. And hit that right arrow right in the bottom right. Miss Woodward, you figured that out yesterday. Good for you. And
Thank you for your help.
you're welcome. It's not that I still want to try to get rid of you, but anyway.
I didn't think you wanted to or anything.
Yeah, but I gotta
get
help
paid
you,
for it.
you know. Yeah. So there you go. Eventually, I'll get rid of you. So there's that, and now we got to what? Square it.
Priority 1 message coming in on
So
secure channel.
equals that number raised to the 2nd power. Copy that down. Now, what do we do with all those? Some of y'all said that a while ago. What do we do with all those numbers?
Sum them.
Add them. Sum. So hit sum
Priority 1
and
message
hit
coming in
enter.
on secure
Somebody's
channel.
blowing up my phone. And that's going to be the numerator for your what? That's going to be the numerator for the variance. So equals this number divided by, I'll do this part for you. 50 minus 1 is 49. I'll do that for you. And there is your variance, and your standard deviation is equal to the square root, or raise that to the what power? 0.5 power or 1/2 power. And there is your standard deviation. Okay, so now I've got my mean is equal to this number over here. My max is equal to this number down here. My median is yeller and equal to this number. So all we need to do is count up. Now remember, that cursor, my little cross cursor right there, is in the middle. How many numbers are above that number? 25. So you just find the halfway point, which is half of 25 is what? 13, right? Make sure, did I do the wrong one? Let me check. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. Yeah. Let me check above this one. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. Yeah, I did. Sometimes when you get big numbers, you have to make sure you're in the center. So I've got 25 above, so that's odd. So I got to hit number 13. There's number 13. So highlight that, blue, and that is, y'all check with StatCrunch. Did they get 0.79 for the first quartile? Somebody check.
I think that's what it was.
Okay, I told y'all to write it down. Y'all didn't write it down. Y'all don't do anything I tell y'all to do you? See, that's why y'all gonna fail in life. All right, so go down here. That's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There's number 13.88. And we're going to color that verde. Come on, say dice. Verde español. No, that'd be in English. English. All right, 0.88, that's equal here. Equal to that number. And that's verde. And now all you got to do is draw your box plot. So let's draw our box plot. That's our handy dandy. And we're going to draw a black line for our number line. And that would be a min of 0.71, a max of 0.97, and a middle of 0.84. Now, what's the distance between 71 and 84? What is that, 13? Half of 13 is 6. So that'd be 76, 77. Add 6 to that, that would be 90. And if you wanted to add 3, that'd be 74. Well, Hubert, you're forgetting the decimals. Okay, we're not designing O-rings for the space shuttle here. All we're doing is fixing a graph, you know, so we can do a box plot. So that's 0.8, that's 0.87, and that's 0.93. Everybody with me? I'm just guesstimating, just giving it some numbers so I can draw a box. Okay, take my blue marker and put 0.79. 0.79 is right in here. Take my green marker, verde, and that's 0.88. And take my yellow marker, and that is, I don't like that yellow, I like this yellow. 0.84, y'all can see it better. And there is my box plot. And that box plot is pretty much saying we got a normal curve. Because this is the center, that's the mid-range. Looks like we got pretty much normal curve. I have no idea what the question is asking, but I bet you $1 to a donut I've answered it. If you do everything that I just did, you're going to be all right. Okay, so let's look and see what they're asking for. Hopefully y'all write this down on your notes, because I'm not going to go back and forth. If y'all don't write down the answers, I'm not going back and forth trying to find them. So let's go and see what they asked for. Okay, they want a box plot. Let's see, what is this of? Determine the sample standard deviation. Somebody check my standard deviation. What is my standard deviation? What did I get with the Excel spreadsheet? Y'all just aren't going to answer me, are you?
Was it 6 or 13?
Y'all didn't write down a single thing I told y'all to write down. 0.062. What did they get? It's a miracle. On the basis of the histogram to the right, comment on the appropriateness of using the empirical rule to make any general statements about the weights of the candies. Yeah, we said it's bell-shaped. Yeah, as long as it's bell-shaped, the empirical rule. Yeah, I mean, that's pretty bell-shaped. Now, if you had a skewed left or a skewed right, you couldn't use the empirical rule. Use the empirical rule to determine the percentage of candies. Okay, this is a good test question. C is a good test question. So here we go. I'm on, well, we have it, well, we have this. Actually, I'm going to go back to the spreadsheet. We're going to draw the curve, and we're going to do it on the spreadsheet. So what goes in the middle of the curve? The mean, right?
Yes, sir.
There's the mean. Now you need to draw this in your notes. Draw a curve and put 0.8384 in the middle. I'm going to do this because all these decimals, I ain't going to do this with a piece of paper because I'd have to ask y'all to punch it in the calculator, and then y'all wouldn't do it, and then it'd piss me off and all that stuff. And I'm going to add the standard deviation here and hit F4, function F4, and then I'm going to copy that over 2 places. That's 3 standard deviations to the left, I meant to the right. And what am I going to do on the left-hand side?
Subtract it.
You subtract the standard deviation, function F4, and copy 3 to the left. I can't draw my curve here, but my curve would look like this. And I'd have a line here and 3 lines here. So I wish I could draw. I'm going to draw it on a piece of paper now that I've got the numbers. Y'all are so blessed. All right, so I'm just going to do the point. I'm just going to do the 2 decimal places because I'm not going to. Let's see, 0.84, 0.90, 0.96, and 1.02, and 0.78, 0.71, and 0.65. This is the test question. They're going to give you a mean and a standard deviation and say use the empirical rule to find out blah, blah, blah. Well, we're not even going to look at the question yet because we ain't finished. We got to do 34 here, 34 here, 13.5 here, 2.35 here, 0.15. I'm sorry. You're right. Is it what?
Yeah, you got it right.
Okay. 13.5 here, 2.35 here, and 0.15 here. Now I'm going to look at the question. And if you don't learn that empirical rule, you might as well just you might as well plan to make a C on the test. Depending on if I like you or not. If I don't like you, then I'll give you a worse test. All right, it says right here, use the empirical rule to determine between 0.714. So I'm going to pull out my pink highlighter. I put too many highlighters in this. I put them in my used candle dishes. I love candles. All right. I put too many in here. This is conspiracy. 0.714 and 0.962. Okay, now I'm not a rocket scientist, but I want you to tell me what you do to find the percentage between 0.71 and 0.96. Somebody tell me what you do.
You'll have to look at the bell curve and look at those percentages.
You have to do what?
You'll have to add them.
You have to add them up. If I could get there. There we go. So I'm going to add 13.5. I'm going to just circle them. I'm going to add 13.5. So I need y'all to add 13.5 plus 34 plus 34 plus 13.5. Well, that's going to be 68 plus 13.5, and 13.5 is dang old 27. Y'all check my math. And that's going to be 84%, I think. 94.
I got 95.
I got 95.
Thank you. I can't add. 95%. So you go down here and you type in 95, and let's see if we know what we're doing. Lord, it's a miracle.
See, we listen to you.
Some people don't. Okay, determine the actual percentage of candies that weigh between 0.71. So we go back to our handy dandy curve, and we'll do this in lilac, Squidward, lilac. Okay, so 0.714 and 0.962. They're asking the same thing.
Nah, that one's actual percentage. So you got to go up to your numbers and you got to actually count it out and get the actual percentage.
Oh, they want you to do. Oh, okay. I didn't know that question was in there. Okay, so we got to go up. Okay, 0.714 and 0.962. So let's go to our spreadsheet. I didn't know that was in there. They must have. That must be new. Pull up our spreadsheet. 0.714. So I'm going to take my handy dandy. Now it said 714, didn't it? That's 71. So 714 would be there through 962. 962 would be there. And I'm just going to highlight those some random color. Let's go with that. All right, so let's count them. 1, got to get to my arrows. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47, 48. I got 48. Did y'all get 48?
Yes, sir, I did.
Yes.
Yeah. So somebody take 48 and divide it by 50.
96%.
48 divided by 50 equals 0.96 or 96%. So actual, yeah, this is a that they've introduced that in there. This 95 against 96. And what they're trying to tell you is the empirical rule is not some fly-by-night thing. It's something that actually works. So that'd be 96%. That's a good test question. Well, let me rephrase that. The content of this question is a good test. You got several great test questions in this problem. The only problem, it's not a test question. It's got 50 dadgum numbers. That takes up too much time at the test. I
Yeah,
barely go 20.
It was very
Okay.
time consuming.
Yeah. Use the empirical rule to determine the percentage of candies with weights more than 9 grams. All right, now 0.9. So let's go back to our 0.9. Somebody add 13.5 and 2.35. That's what, or 5. That's 18.5%. So that's going to be 18.5. I hope they don't ask us to count again because I'm starting to get irritated. After C, I get irritated. Okay, somebody, what'd I do wrong? 13.5 plus 2.35 plus 50 points. That's 2.5. Oh, 2.5
I got 16.
is 16. I added wrong. Okay, so it's still, I added wrong. I'm sorry. 16. Sorry. Okay, this is getting irritating. 0.9. Weigh more than 0.9. I'm going to do this one and that's it. Then we go on to another problem. 0.9. So let's go to 0.9. And that's these right here. And I'm going to highlight those orange. 1, 2, 3, 4, 5, 6, 7. 7 out of 50. Somebody do that for me.
0.14.
7 out of 50 is equal to 0.14, which is 14%. And we got 16%. Okay, how many more questions they asked you?
I think that's the last one on that one.
Okay. Now, let me say this one more time. If this question had 10 or 15 or maybe even 20, this would be a good test question. But the A through E, well, A through F excluding the actual, I mean that's okay for a homework question, but some of this is a good test question. If you could do this test question, you can handle my test, that's for sure. Okay? So that's another good one. Oh Lord, they done logged me out. Hopefully that's going to change in the future, especially with this.
I'm glad you solved that through though, because I was wondering if it was just me that was taking that long with that problem, or if it really was that time consuming.
That problem is just it's a good homework problem. And see, you're not coming on when you're talking. You're not coming up. I don't understand that. You're supposed to come up. It's supposed to put you on. Oh well. Unless you got your camera off, you may have your camera on. All right.
Yeah, I don't have it on.
120. Okay, I guess that was that question right there. Ms. Cersei, I hope that helped. She may be in the online class. That's 23. That takes care of all of those. Miss Billy, you okay on that one? Miss Woodward?
Yeah, that helped a lot.
Okay.
It makes sense now.
Okay. And 23. Okay, to 3.2, 35. Miss Billy and Miss Woodward are sending me the same questions. That's good. That means that these questions are either time consuming or they suck, one of the two. 3.2, 35/11. First of all, is it a test question? Eventually, it'll come up. Oh yeah, this is a test question. And it looks like this may be, oh, this is Chechnyov's, and we don't use this. It is not a test question. I don't use Chechnyov. I can't even say his name. Okay, so what I do is I just pull up the view and example here, and I show y'all the formula. Here's the formula. Chechnyov's inequality is stated right here. 1 minus 1 over k squared times 100. I don't even think this formula is on the formula sheet because nobody uses this. Okay? And it says at one point on the average, we'll just do this problem together and then y'all can apply it to the homework problem. But this is not a test question. Continue. So you're going to type in 1 over 3, and that 3 comes from up here. Where is the 3? 3 standard deviations. Right there. Okay? And what they're doing is they're doing the same thing as the empirical rule, only Chechnyov said that empirical rule wasn't good enough. So I'm going to do my own rule. And that's what he's doing. Okay, so the first question says, what percentage of gasoline stations had prices within 3 standard deviations? So he's saying this. The empirical rule which is used most often, let's see, what do they say? Average price of $3.73 I need y'all to use your calculators here. So somebody take your calculators. I need somebody to add okay, it's only 8 cents. I thought it was like $1.08. Okay, 8 plus 73 is 81 cents, 381.
Yes, sir.
And 8 cents here is 389. And 8 cents here is 97, right?
Yes, sir.
397. And back up here, 8 cents off of this is going to be 365.
Yes, sir.
Somebody kept my math. And 8 cents off of this is 357.
Yes, sir.
And 8 cents off of that is 349.
Yes, sir.
Okay. Now, what he's saying on the question, he's saying, what percentage of gasoline stations had prices within 3 standard deviations? By the empirical rule, you're talking 98%. If you add your empirical rule up, here's 3 standard deviations. Let me get a highlighter, just because I want to use a highlighter. 3 standard deviations with the empirical rule. And I'm bringing the empirical rule in because the empirical rule is one of the most important things for you to learn in chapter 3. And if I can use it to compare it to the Chesney-Off, whatever his name is, then it's good, because the more you see it, the better. 34, 13.5, 2.35, and 0.15. What are you doing, Berlioz? 13.5, 2.35, and 0.15. Berlioz wants to be on TV. Okay. So that adds up. That's 97. Is it 97? 99.7%, I think. Somebody add all those up. So with the empirical rule, 99.7% fall within 3 standard deviations. With the thing about Chesney-Off or Chesney-Off or whatever his name is, you don't need a graph. You just have the formula. Okay? With Chesney-Off, he says, how do you spell his name? I never have been able to say his name. Chebyshev. Chebyshev says 1 minus 1 over k squared multiplied by 100, and that would be 1 minus 1 over 3 standard deviations squared, which would be 1 minus 1/9, which would be 8/9, right? Right? 9/9 minus 1/9 is 8/9. What is 8/9 times 100? Somebody take 8/9 and multiply that. Okay, it's right there. 89%. So Chesney-Off says, let me get this in here for you. Chesney-Off says that empirical rule is not right. It's 89%. Okay? All I got to tell y'all is if you go into any probability and statistics course, you're going to, in a later, like a 300 level or 400 level, you're going to be using the empirical rule. Okay? So what if it asks the next question? It says 1.5 standard deviations. Well, let's look at the empirical rule. 1.5 standard deviations. I'm going to use the green pen again. 1.5. There's 1. There's 0. There's -1, -2, -3, 2, and 3. So 1.5 would be there and there. What's half of 13 and a half? 6.75. So that's 6.75, and that's 6.75. So what's 68 plus 6.75 plus 6.75? That's going to be 68 plus 13.5, and 68 plus 13.5 is, dang on, 81.5.
Yes, sir.
So by empirical rule, within 1.5 standard deviations is equal to, I done forgot, 81.5%. So let's see what Chesnioff says. So I want y'all to do 1.5 squared for me. 1 minus 1 over 1.5 squared times 100. What is 1.5 squared?
It is 2.25.
Okay, so 1 minus 1 over 2.25. That's 1 minus 1/2. That's going to be 1/2. It's going to be around 50%. What does it come out to be?
It was like 55.6.
55.6. So Chesnioff says it's not 81%, it's 55.6. Okay, so does that help you? Let's do one more. It says, what percentage, okay, I'm sorry. Yeah, I didn't read the rest of the question. What are gasoline prices that are within 1.5 standard deviation of the mean? Well, we got that right here. We're going to have to add, what's halfway between 381 and 389? Well, we said that the standard deviation is 8 cents, so that'd be half, 4 cents. So what would that be? 4 cents right here would be 385, and 4 cents from here would be 361. So between 361 and 385, that should be your answer there for B. So let's go down to B. Well, okay, there's B, 55.56. We got that. Yeah. And should come out with 361. We did. And 385 is our second one. And how did I do that? I just went halfway between 381 and 389. We know that the standard deviation is 8 cents. So what's half of 8?
4.
4. So 381 plus 4 is 385. 365 minus 4 is 361. That's why the empirical rule is so important. Okay? It's so important. If you don't know it, it's going to haunt you. Now, what does the last one say? What is the minimum percentage of gas that had prices between 357 and 389? Now, by the empirical rule, 357 and 389, I'm going to go with a yellow. Let's see if this highlighter works. Oh, that's pretty dead. I need to throw that one away. Where's my other highlighter? I got another highlighter. Where is it? There it is. Okay, what was the numbers?
3.57.
357 and 389.
Yes, sir.
357, that's close enough right there. 357 and what? Well, that's within 2 standard deviations. So With the empirical rule, you just add up 13.5, 34, 34, 13.5. But with Chesney-Off, you're going to be that's going to be within 2 standard deviations, because this is 1, this is 2, this is 1, this is 2. So Chesney-Off would be 1 minus 1 over 4, which is 3/4, and 3/4 is 75.75 times 100 is 75%. So 75 would be your last answer. Two standard deviations, there you go. And it should be 75%. There you go. So Chesney-Off is something good to know, but it's for a homework problem. Does that help y'all good? I know Miss Billy and Miss Woodward sent that. Does that help?
Yes, sir.
Yeah.
Miss Culberson, I think she's in the online class, so that should help all 3 of y'all there. Oh, we're making good progress. 3.2, 46T. I don't know what 46T is, but it's number 12 online. All right. Okay, I'm not even going to look at the directions because I've got a little tab here. And guess what? We're going to put it in. I'm going to put it in Excel. You can put it in StatCrunch if you want to, but I'm going to put it in Excel because that way I can show y'all, by hand what everything's doing. Okay. Did you tell Lauren that we get her windshield wiper when she got here?
Yeah.
Tell her, please. Okay. It didn't come up. Let's see if it's in here. It didn't put it in Excel. Let's try it again.
I think you gotta open it at the bottom, Hubert.
Well, I thought I did. I did that one. That's not it. Don't save. Okay. That's the one we did a while ago. I don't know why it's asking me to do this and do that. Oh, you're talking about right here, aren't you?
Mm-hmm.
Thank you. Who was that, Miss Woodward?
Yes, sir.
You're still going to fail.
I'll say, you still trying to get rid of me?
Yeah. The cat's going to scratch your eyeballs out.
I'm trying to call them.
All right. There we go. There's our 2 whatevers they are. I'm looking to see if they're in order. Let me look at the question again. Does it matter? Yeah, it's just, this is bond mutual funds. This is stock mutual funds. Okay, they're probably going to compare the 2, but we're going to go ahead and put them in order. So I'm going to move these. I'm going to Control X, Control V. I'm going to put these in order. Go to Data, go to A through Z, and I'm going to put these in order. A through Z. Everybody with me? And then I'm going to go over here and I'm going to type in mean, median, mode, range, mid-range, variance, and standard deviation. We're not going to do a 5-number summary on this one because there's only like, what, 8 numbers. I mean, you could do it, but it'd be very small. We'll go ahead and do it because, heck, the dadgum book may ask you to do it. 5-number summary. That's going to be the mean, the first, second, third, and the max, and the mid-range. And the mid-range is going to be equal to the median. And that's going to be yellow. And this is going to be yellow. And these two are going to be yellow. So we'll go ahead and do, let's go ahead and do the sum and add all these up. Divide by 8, I assume. There's your, whatever, what I type in wrong. I suck. I hit multiplication. There you go. Median is going to be equal to, parentheses, the 2 middle numbers. And what do you do with the 2 middle numbers?
Average.
Add them together and average them. Yes, divide by 2. I'll make these a little bit bigger. Miss Billy looks like she's straining, so I'm going to make it a little bit bigger. Take these 2 out. I'm hoping I got everything. Let me delete one more. Can y'all see that a little bit better?
Yes.
Yeah.
Okay. And let me make this a little bit wider and make this a little bit wider and make this a little bit wider. There we go. All right. So mode, I don't care about the mode. You pull that out if you want to. Range is equal to the highest minus the what? What the hell? I don't know what just happened there. Equals this minus this. Mid-range is equal to the highest plus the lowest, or the lowest plus the highest, divided by 2. And where can all these formulas be found?
Stat sheet.
On the stat formula sheet that I gave y'all. All right, so here I'm going to do this minus this, shift F4 or function F4, copy that. Okay, let me do that again. It didn't like what I wrote down. Equals this guy minus this guy, function F4 equals. Thank you. Copy that down. Sometimes if you don't grab it right, you got to make sure that the white cross turns into a black cross right there. There you go.
That's where I was messing up.
Yeah, a lot of people do that. They can't figure out what's going on. And then equals this raised to the 2nd power. And copy that down. Do a summation. And that is the numerator for the variance. Divided by 7. And raise that to the 1/2 power or 0.5 power. And there's that. This is not the mid-range. That's not right. That is equal to that. And this is equal to that. Sorry about that. Of course, y'all were going to say something, weren't you? No, you wait till the end of the problem. That way you do the whole thing over again. All right. There you go. All right, so the mean is equal to, of course, the lowest. The max is equal to the highest. And there's my 2.4 right there. How many numbers are above my white cross cursor?
3.
Nope.
4.
4.
4. So I got to take these two, and we'll color those pink. No, that's more of a mauve. There we go. So I got to do those right here. So I'm going to color that pink. And that's going to be equal to parentheses, the lower one, plus the higher one, or the vice versa, divided by 2. And down here be those two, and we'll color those aqua. And that's going to be equal to parentheses, that number plus this number divided by 2. And there's your 5-number summary. And what you could do if you wanted to, but it probably won't be accurate. Control C and go down here. Control V, but I'll have to check to see if everything works out there. Now, first of all, what are you doing? You're comparing. So I'm going to go here and I'm going to highlight that Verde. I'm going to highlight that Verde. And I'm going to highlight that Verde. I'm going to highlight this some other color. So that means the spread. And I'm going to highlight these Verde, but I don't know if those are accurate numbers down here. I'm going to have to check because the variance and the standard deviation is not right, so I'll have to check those. Mid-range is, and the standard deviation is at burnt orange. Okay, so let's check these down here. Summation, all these numbers divided by 8. Oh, we didn't do this, that's why. Yeah, it's not going to do it. So let's just go ahead and read. Oops, I screwed that up. Let's try that again. Control X or Control C. Control V. It might have done it correct, but let's go ahead and check it. Equals this number minus this number, function F4, enter. Yeah, they're different. And equals this number raised to the second power. And copy that down. And I think the median would be right, but let's check it. That's going to be yellow. And that's going to be equal to parentheses this guy plus this guy divided by 2. Yeah. I think a lot of, somebody check the range and the mid-range and see if I'm about, I think I'm close. Yeah, these are not right because the min is the max. Is the max 9 point? Yeah. 8.35 is the mid-range. Okay, somebody tell me which data is closer. Looks like the first set. Why? Because the spread is what?
Smaller.
The spread is smaller. Let's look at this. 2.6, 2.4, 2.7, 8.2, 8.0, 8.35. So those are pretty close, but I'd say probably your first set of data is probably going to be your better set. And then you could do a box plot, but that box plot, I'm going to tell you, it's not going to be very accurate because you only got 8 numbers. Let's see what they asked for. Now, y'all write down these numbers right quick so I don't have to go back and forth, please. Well, I'll just forget it. I'll just do this because y'all won't write them down. And I'll end up going back and forth 15 times. Okay, what do they ask for? They ask for, I bet they ask for everything for each group, don't they? Like A through F.
Mm-hmm.
I kind of figured that. So for the first group, 2.575, standard deviation, it says round to 3 decimal places. I got 0.669, so I'm going to type in 0.669, but I'm going to do this first. Well, 0.669. And then they're going to ask for the mean of the data set for the stock is 8 point, what is it, round to 3? 8.213.
Priority 1 message coming in on secured channel.
And the standard deviation is 0.903. And I don't know what they're going to ask for now. Based on the standard deviation, which one's the first group? Bonds? The second group has more spreads. The stock has more spread. And we feel good about ourselves. What proportion of the bond, this bond right here, are within 1 standard deviation of the mean? Okay, then we're going to have to do our numbers. So I'm going to go here. Go away. All right, I'm going to go do I'm going to do it on the calculator. I'm going to do it on the spreadsheet. So I'm going to do my curve right here in the middle. So equals the mean. And then I'm going to equal this plus standard deviation. F function F4. And I'm going to copy 3 places to the right, 2 more places. And then minus standard deviation, function F4. And I'm going to copy that 2 places. And then I'm going to take all that, Control C, put it right across the mid-range. Okay, so if you drew your curve here, now they're asking, let's see what they're asking again. They're saying what proportion of the bond mutual funds are within 1 standard deviation of the mean. Now, I don't know if they're actual or by the empirical rule, but by the empirical rule, 1 standard deviation of the mean would be here and here. And that would be 68%. But I don't think they're asking that. They may be asking, I don't know. how many are actual? 1.9 to 3.2. 1.9 to 3.2. How many is that? 1, 2, 3, 4, 5. What's 5 out of 8? Somebody give me 5 out of 8.
I got
0.625.
yeah.
62.5. So
Yes.
I'm gonna say
0.625.
yeah, that's 62.5%. I'm gonna say 68 right here because that's the empirical rule. Let's see what it says. They may want the actual. Okay, so 62. What'd you say? 62.5.
Yes, sir.
That's actually counting the numbers. Okay, I have no idea how to do it then, unless I'm rounding wrong. Oh, 3 decimal places. 0.625. There we go. What proportion of stocks are within one standard? Okay, now I got to go down here and do the same thing here. So take your curve. You need your curve right here. And this is a standard deviation. And this is one standard deviation. So 7.54, 8.88. 7.54 and 8.88. So what's 3 out of 8, or 4 out of 8? That's 1/2. So that's going to be 0.5. Hold on, I'm trying to find out where I'm at. I'm going all over the place here. That should be 0.500. Okay, I don't know. Somebody, 4 out of 5, 4 out of 8, isn't that 0.5?
Yes.
I think it's 0.625. Let me look and make sure I did it right. Hold on. Let me go check my numbers right here. 0.8215. Maybe I need to do that. Still wouldn't make any difference. Okay, one standard deviation is 7.54. That's right here to 8.81. Is that not 4? Now, if they wanted the empirical rule, that'd be 68%. I don't know where they're getting that answer. Somebody check my numbers and make sure, but I've been getting them all right. I don't know if that's, I don't know where they're getting 62.5 because that's 4 out of 8. Anybody got any input on this one?
I'm lost too right now.
I don't know how they get that 62.5. Let me nobody's going to say anything, huh? Stock mutual funds, that's these right here. Let me check my numbers. 9.6, 9.6, 9.3, 8.6, 8.3, 7.8, 7.6. All my numbers are right. Let's move on. I don't know how they got that 625. I really don't, because it's the same answer as this one. How do you get the same answer? No. There's something not right there. You're not going to have the same. What was the 0.625? Was that 5 out of 8?
Yes, sir.
I think they've got an error here because that's not, I want y'all check me. I mean, y'all check me one more time. between 7.54 and 8.88. 7.54. I bet you $1 they included that 7.4.
7.6. Damn, 7.4.
And 9 is right there. Now, how many is that? I guarantee you they counted that 7.4 is what they did. Okay, my answer, I think, is 50%. I think that's the correct answer. Unless y'all prove me wrong, we're going to go with that's the answer. Which I would not give you all this on the test. This would take the whole test, just doing all these questions. So this is not a test question. The content is good test questions, but I would not give you one of these for a test question. The coefficient of variation is defined as the ratio of standard deviation to the mean of the data set. Standard deviation over the mean. So somebody take the standard deviation of the bonds. Let's say bonds, that's the first set. So standard deviation over the mean. Okay, standard deviation. Somebody, I'm just going to do it right here. Equals standard deviation divided by the mean.
And on that last question,
Write that down.
they
What?
didn't. On the last question, they did include the 7.4 because I went back and worked it without rounding, and it was like 7.3 something.
Yeah. Okay. Well, thank you for saying that. All right. Somebody put down 0.259892 for me. And I'm going to copy that, Control C, and I'm going to go down here and 0.109963. So there's the two coefficient variation or whatever. I don't use that on the test, but go ahead and write down 259,892, 109963. And I'm going to make this small, and I'm going to try to get it to where I have both of them on there. That's close enough. It says, doesn't say round, does it? There it is. 3 decimal places, 25260. And stock mutuals, 110. Yeah, we're getting all the answers right because if we got all the answers wrong, then I would say we're doing something wrong. But that is just an observation of 3.4. Okay. Based on the coefficient of variation, stock mutual bond has a larger spread. Oh my gosh. I'm not doing anymore. I'm sorry. What do they?
That's how I
what do
felt
they-
when I was doing it last night.
What?
So that's how I felt when I was doing it last night.
Okay, this. What? In the table below, the set of data has height in inches. So they're giving you a third problem.
Doesn't that have anything to do with the problem?
This has nothing to do with this problem.
Yeah, they give
Okay,
you
we're
that
gonna
problem
move
to
on.
show
I'm
that
going to
the
move on. You're going to do the same thing I just did with these. I don't know why they're giving you a separate problem in the middle of bonds. I could understand if this was bonds versus savings accounts or something like that. But this is, what is this?
they do it to show that the units don't matter in the end with the coefficient or something like that.
Okay, well, I'm not going to test you on that. So let's move on. I want to get all these questions. And I've only got like what, 8 minutes left? What time
You got
is
until
class?
2:35.
Okay. All right. Thank you for being honest. Miss Woodward would have told me that class was over at 2:15. All right.
Well, I was going with 2:30, but yeah.
All right. So let's delete that one. Does that help you out, Miss Billy?
Yeah, that helped a lot. I think I'll be able to get the other parts since they're just the same thing.
Okay. that is not a test question. All right, 3.4, 21/12. 3.4, 21/12. Now this is where we haven't been over anything yet, and you need to write down those formulas. Okay, I'm gonna write them down. Well, I'm not gonna write them down because I pulled them off of that. I should have pulled them off and copied. But all right, so here's the question, and these are probably going to be test questions. I can tell you that right now. Most of your Z scores are going to be test questions, unless they're like 15 parts long. The accompanying data represents the miles per gallon of a random sample of cars with a 3-cylinder 1-liter engine. Compute the Z-score corresponding to the individual who obtained 35.9 miles per gallon. Interpret the result. Determine the quartiles, blah, 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 blah. Okay, I don't have a problem with this one. I do have a problem with how much they don't give you a mean and a standard deviation. Usually, they give you a mean and a standard deviation. Are they going to do a mean and a standard deviation? They have to, because the formula, there's the mean.
Try clicking on that blue box.
Oh, I see. There's a data. Okay. So first of all, we're going to do this. We're going to go, I didn't see the, okay, so I'm going to go to the spreadsheet. Oh, no, I'm not. I'm going to go to StatCrunch. I'm going to go to StatCrunch, and I'm going to hit Stat and just find the mean and the standard deviation. That's the best way to do this problem. So I'm going to go to Stat, Summary Statistic, column, hit the variable, and hit Compute. Now you need to write this down. Mean is 38.9625, and the standard deviation is 3.46683, blah, blah, blah. And I bet I won't be able to copy those. Let me see if I can copy them. Nope, I cannot. So I got to write it down. So the mean is equal to, or X bar is equal to, and I covered it up, 38.9625. 38.9625. And the standard deviation is 3.4668382. 3.4668382. Okay, so that's all I need from that. So I'm going to take that, minimize that. Now, the Z-score, and you need to write this down because this is a test question. Z-score is equal to X minus X bar over standard deviation. So that's going to be equal to 35.9 minus 38.9625 divided by 3.4668382. Now I'm going to do that on a calculator because it just, and we should have wrote down the quartiles also, but I didn't. Maybe I can pull it up again. Okay, so here's my calculator, clear, and I'm going to do 35.9 minus 38.9625 divided by 3.468382. I got negative 0.883, well, 0.88. And that means, I'm going to show you how you use z-scores. You usually round z-scores to 2 decimal points. Write that down. Z-scores are usually 2 decimal points. So if you were to write a curve, and this is going to be in chapter 7, so you got to get used to it. The z-score is 0. I mean, 1, 2, 3, -1, -2, -3. Our 0.88, the 0.88 we just calculated is right in here. So we know that this is 0.15, 2.35, 13.5, 34, 34, 13.5, 2.35, and 0.15. Now the question may ask, what percentage by the empirical rule is below -0.88? It's not going to ask that because there's no way you can tell. You can just estimate it. And that's the estimate right there. You would say, well, it's 13.5 plus 2.5 is what, 16? And 32 divided by 4 is, that's an 8. So that's going to be close to 0.75. So 3 into 34 will be 11. So that's about 11%. 11 and 16 is what? 27%. So I would say by the empirical rule, it's a round squiggly line with a dot on it, 27% or 0.2700. Write down area equals 4 digits. And we'll get to that later. Area is equal to 4 digits. But that's all they want right now. Now let's go back to the StatCrunch and get the quartiles. And I should have wrote everything down, but I was trying to hurry. And why didn't it pull? Oh, I didn't copy it. Go into StatCrunch. And the reason I'm using StatCrunch is because it'll give me the values a whole lot quicker than doing it in Excel. And I'm running out of time. And that's going to give me stat, summary statistic, column, variable, compute. Okay. Now, your first quartile, write this down. Your first quartile is 36.85. 36.85. That's your first quartile. Your second quartile is your median. Your median is 38.55. And your third quartile is 40.9. Now you have to go to your formula sheet. What is the interquartile range? That's your third minus your first, isn't it? Somebody look at the interquartile range. What is the interquartile range?
That's right.
IQR. It's equal to the third minus the first, isn't it?
Yes, sir.
So that's going to be 40 minus 4.9 minus 36.85. Somebody give me that number.
4.05.
4.05 is your interquartile range. Now you're going to use that interquartile range to find your parameters for the upper side and the lower side, and that's the formula under the interquartile range. Somebody give me that formula. One of them's on the upper side, one of them's plus, one of them's minus. So what is it? It's 1.5 something. What is it?
So I got to go back and look at that one.
There's a Q1 minus 1.5, and then there's a Q3 plus 1.5.
Okay, give me both of them. Just say them both. What is it?
The lower limit, it says Q1 minus 1.5.
Q1 minus 1.5 of what? It should be.
IQR. I don't know.
Okay, let me go pull it up.
Oh,
I thought I had them up. Now I got to go back. Oh, I should have downloaded it. Teams. I'm trying to go back to the Teams page. There we go. 120. Just give me a second. Files. Formulas. And I'm pulling up the curve. I didn't pull up the curve. I want the formula. Hold on, I'm waiting for it to pull up. It's kind of taking this time. Okay. The lower limit. Well, now it's changing over to PDF. Please hurry. Now it's not doing anything. Okay, now it's coming up. Sorry about this. Okay. The lower limit, like you said, the lower limit, there it is, IQR. That's what you just found out. I knew it was multiplied by something. All right. It's called the lower limit. The lower limit is equal to Q sub 1 minus 1.5 interquartile range. And the upper limit is equal to Q sub 3 plus Q sub 1. I thought it was Q sub 3. Is it Q sub 1 or Q sub 3?
3.
Say again?
3.
I thought it was 3, but I can't see it. Hold on, I'm pulling it up.
Yes, 3.
Yes, Q sub 3. I thought it was. Q sub 3 plus 1.5 IQR. So somebody take 1.5 of 4.05 for me. Tell me what that number is. 1.5 of 4.05. What is that?
I'm getting 6.075.
Okay. 6.075.
Yes, sir.
Okay, so our quartile here is 36.85. 36.85 minus 6.0 what?
0.75.
Okay, that's your lower limit. And your upper limit is 40.9 plus 6.075. Now somebody give me the lower limit.
That is 30.775.
30.775 is your lower limit. 30.775. Somebody give me the upper limit.
46.975.
46.975. Now, what does that do? That basically tells you, where's the outliers? The outliers are right here. After 3 standard deviations. Everybody with me?
Yes, sir.
No.
They're telling us that the lower limit is 30.78. And the upper limit is 46.98. Now, you could do this by the empirical rule. We just did it by z-scores and quartiles. So if I was 28 years old, I would be an outlier. If I'm 53 years old, I would be an outlier. Now, if you were doing it with the empirical rule, let's see, what was our mean? Our mean was 38.9. So I'm going to do this in a different color. I'm going to do my peach, or my pink. I'm going to do pink. So if I was doing empirical rule, this middle one would be 30, I'm just going to say 39. And my standard deviation is what? 3.5. So we're going to say 4. So 4 would be what? 43, 47, and 50 what? 1.
1.
Down here, 39 minus 4 is 35, 31, and 26, or 27.
Yes, sir.
So by the empirical rule, if I was 24 years old, then I would be an outlier. If I was 53 years old, because that's 51. So by the empirical rule, my upper is 51 and my lower is 27. By z-scores and interquartiles, my lower is 31 and my upper is what? 47. So that's what you're doing with the interquartiles. The interquartile range helps you find the what? The outliers. And the question asks, done. Compute the z-score. The z-score corresponding to the individuals. What do we get for a z-score? Negative 0.88 is 0.88 standard deviation below the what? Below the mean. Just look at your graph. Look at the graph. Where is negative 0.88? It's below the what?
Below the mean.
Mean. It's to the left of the mean.
We're over time, Hubert.
I know. Let me finish this problem. And Q sub 1, what do we say, is 36.85. And this is a test question. Q sub 2 is 38.55. And Q sub 3 is
40.9.
40.9. And compute the interpret the interquartile range. We said it was 4.05. I don't know which one it is. I'm just going to pick one and put 4.05. I'm in a hurry. Of course, I didn't pick the right one. Check. Check. All right, write down B. That's a generic. All you're going to have to do is just pick B that says 50%. Pick B and put the interquartile range in there. And now the lower is 30.78. 30.
It says do not round, so 30.775.
Okay, 775. Thank you. And the other one is 46 point what?
0.975.
And they might ask you, is there any outliers? Okay, so you look at your table. You look at your table. Do we have any that are below 30.77?
I don't see any.
I don't see any. Do we have any above 46.98?
There's a 49.
Okay, so we have one. 49.
Yes, sir.
That tells you what your outliers are. I don't like having a bunch of, but I like this question because it sums up what 3.4 is. And we'll probably have some more questions in the next class because Tuesday will probably be our last day going over chapter 3. Okay, so let me go ahead and end the, I gotta get back to the video, sorry. I don't know, y'all should be able to, okay. Let me get back to general. I'm trying to get there. Not. I can't get away from, there we go. Join. I'm coming back to the meeting is what I'm doing. And I'm going to hit. Okay, one thing I do want to talk to you about, well, I don't have time, so I'm just going to stop the recording and stop recording.